Greetings to Dr. Noor AYUNNI. I'm N.Balakrishnan, matrix number 820A1911. Today I would like to present on data description for the study. This data contains 1,339 observations altogether. The minimum insured age is 18 years old and the maximum insured age is 64 years old that could be identified from the study. There is female and male genders in this study, which contains 676 people are male and 662 are females. The number of males are higher than females in this analysis. Higher body mass index BMI is 53.13 and the minimum BMI is only 15.96. 574 insured are childless. 324 insured are having only one kid, 240 insured are having 2 children, 157 insured are having 3 kids, 25 insured are having 4 kids. Meanwhile, only 18 insured are having 5 kids. Through this, we can identify only least insured are having more kids compared to majority are childless. The least number of insured are smokers as much as 274 compared to the non-smokers are as much as 1064 insured. This data consists 4 regions. 324 insured are from Northeast, 325 insured are from Northwest, 364 insured are from Southeast and 325 insured are from Southwest.
A C dataset has been randomized and coded by using the SPSS software according to the recommendation. It can be confirmed that the data that being used for this study is fair and did not apply any bias. Failure to randomize encoding the dataset may lead to the outcome of this study may be not relevant to be used. Thank you.
Assalamualaikum and hello everyone. My name is Muhammad Hanif bin Norazahar. My matric number is 820A1487. Today I will present 3.0 numerical descriptive measures. There are 3 common items in numerical descriptive measures. So first, measure of central tendency. Second, measure of position. Third, measure of variation. So first we will move to the measure of central tendency. There are 3 most common measures of central tendency, which is mean, median and mode. So mean for variable xh is 40.47, median for variable xh is 41.07, mode for variable xh is 22.75. Next, for variable y charge, mean for variable y charge is 14,285.40, median for variable y charge is 9,558.10 after roundup, mode for variable y charge is 6,426.91. So next we will move to the measure of position. Information. A measure of position is composed quartiles and interquartiles. Q1 or first quartiles for variable xh is 26.69 after roundup. Next, Q3 or third quartile for variable xh is 52.66 and interquartiles range equal to Q3 minus Q1 or third quartile minus first quartile is 25.97. Variable y charge, the Q1 or first quartile for variable y charge is 5,453.71. Q3 or third quartile for variable y charge is 17,575.69. Interquartile range for variable y charge is 12,121.98. So next is measure of variation. So for the measure of variation, there is 3 items also: range, variance and also standard deviation. So range for variable xh is 46, variance for variable xh is 210.16 after roundup. Standard deviation variable xh is 14.50 after roundup. So for the shape of distribution variable xh, the graph being sketched by using mean, median, and mode. So mean is 40.47, median is 41.07, the mode is 22.75. So because of mean less than median, the shape of distribution is screwed to the left. Measure of variation for variable y charge. So range for variable y charge is 46,690.72. Variance for variable y charge is 156,353,440.30. So for the shape of distribution variable y charge, the mean is 14,285.40, the median is 9,558.10, the mode is 6,426.91. So because of the mean is greater than median greater than mode, the shape of distribution screw to the right.
My name is YIREH XAVIER, metric number A20A1326. We have represented the data set given graphically. Those illustration includes histogram and frequency polygon. For variable x, which is the age of the insureds, a histogram is sketched to divide and organize the group of data to user-specific range, as shown in figure 1. The vertical line scale measures the frequency, which is the number of insureds, and the horizontal line measures the midpoint, which is the age of the insureds. We realize people at the age of 18 to 24 at the midpoint 21 has the highest number of insureds, which is 18, whereby people at the age of 32 to 38 with the midpoint 35 has the lowest number of insureds with life insurance, that is 8. For variable y, which is the value of life insurance per year in RM, a frequency polygon is drawn. From that, we realize that 40 insureds of 87 were charged from 1,826.84 to 8,496.942 at midpoint 5,161.891. Each year, which is the highest, and only 3 insureds were charged at the value from 28509.252 to 35177.354 ringgit per year, which is the least at the midpoint 31843.303.
Selamat sejahtera, Doctor. My name is CHEN and metric number is A20A2031. Now I'm going to present about 5.0 statistical analysis using SPSS. First, 5.1 numerical descriptive measures. In this part, we make a comparison between SPSS and manually. The left-hand side was shown the calculation of measure tendency of central, measures of position, and measures of variation by using SPSS. In contrast, the right-hand side was a calculation manual. In sum, using SPSS was easier than manually and the result obtained more precision. 5.2 hypothesis testing. In this part, we perform hypothesis testing by using the normality, t-test, and also the ANOVA. So the first one is the normality. The test of normality for 3 variables, age, BMI, and charges are shown at table above. The Shapiro weight test of normality of variable age on the residuals give a p-value of 0.001, less than the level of significance 0.05. Thus, the test rejects the hypothesis of normality when the p-value is less than or equal to 0.05. Then the second one is for the variable BMI on the residual gives a p-value of 0.235 more than 0.05. Thus, the assumption of normality of the residual terms is met. The last one is the variable charges is 0.00 less than 0.05. Thus, the test rejects the hypothesis is normality when the p-value is less than or equal to 0.05. The next one is the ANOVA, and it is showing the details for the 5 main steps. The step 1 is state the hypothesis. H now equal to nu1 equal to nu2 equal to nu3, and HA equal to at least one of the mean is different from the others. Step 2, state the level of significance, which is alpha equal to 0.05. Then step 3, we use SPSS to conduct a result for the ANOVA. Step 4, decision rule. Reject hash null if f greater than f alpha v1 v2. Critical region f alpha, which is 0.05, 78 is v1, at is v2 equal to 2.97. 2.97 is referred from the statistical table. Step 5 conclusion. Since f greater than f 0.05, 78 at equal to 2.6 at 1 less than 2.97, fail to reject hash null. Then the last one is about the t-test. The first one, we state the hypothesis hash null equal to nu equal to h. Hash a is nu not equal to h. So step 2, state the level of the significance, which is alpha equal to 0.05. Then step 3, we also use the SPSS to conduct the result of the t-test. Then we select independent sample test in the ANOVA. Step 4, decision rule. Reject hash null if t greater than t alpha divided by 2, comma df. Critical region t 0.05 divided by 2, comma 85 equal to 0.025, comma 85 equal to 1.990. 1.990 also is referred from the statistical table. Then step 5 conclusion. Reject hash null since t less than t alpha divided by 2 df. So it's the negative 14.263 and negative 15.31 less than 1.990. Therefore, we can identify that the mean is not equal to the charges. Then 5.3 correlation analysis. We use scatter plot and the correlation analysis table in this part. In the scatter plot, graph 1 plots charges, which is represent about value of life insurance per year against BMI. It is seen that the increase of BMI, the risk in the value of life insurance per year. Graph 2 plots charges against age. Generally, the older the person, the higher value of life insurance per year. On the other hand, graph 3 plots age and BMI. Generally, the older the person, the higher is the BMI. Then, the table correlation analysis shows that the R value between age and charges is 0.373, and it was considered a moderate correlation, while BMI and charges are 0.162, is thought to present a weak or small association. Thus, charges are associated with both age and BMI. Furthermore, the R value between age and BMI is 0.207, less than 0.85. Therefore, perhaps there is no problem with multicollinearity. 5.4 Confidence interval. This table shows that the 95% confidence interval for age lower boundary is 132.293, while upper boundary is 495.765, where the value of 0 does not fall within the interval, so indicate that age is a significant predictor. Meanwhile, the 95% confidence interval for BMI lower boundaries is negative 237.374, upper boundary is 602.748, where the value of 0 does not fall within the interval, again indicating BMI is a significant predictor. 5.5 Prediction modeling. We use ANOVA, model summary, and coefficient in this part to construct a multiple regression linear. First, from the ANOVA table, we can notice that the dependent variable is charges, and the predictor, which is the independent variable, is our age and BMI. Then, in the model summary table, the R-square value is 0.146, which means that 40.6% of the variation in charges can be explained by age and BMI. Then, the last one is coefficient table. From this table, we can construct a multiple linear regression. Our equation is charges equal to negative 4,184.182 plus 314.044H plus 182.687 BMI. So from the multiple regression equation, it shows that BO is negative 4,184.182 84.182. Therefore, charges for every unit increase in age are expected to increase by 314.044 provided the other variables BMI remain unchanged. Similarly, for every unit increase in BMI, charges will go up 182.687 provided the people are still of the same age.
Finally is concluding remarks. Only 60 observations were randomly selected from 1,339 observations in order to determine the average of the greatest annual value of life insurance. 3 variables were considered as the key variables in this study based on logic, which is age, charges, and body mass index, which is known as BMI. According to the table below, there are differences between manual calculation and SPSS calculation. For the firstly, frequency. For frequency, as manual calculation and SPSS calculation are the same. Meanwhile, for the mean, median, and mode, there are some differences between manual calculation and SPSS calculation. For manual calculation, the mean is 14,285.40. Meanwhile, for the mean for SPSS calculation is 13,984.5633. The median for manual calculation is 9,558.10, and for the SPSS calculation is 8,835.2650. The mode for manual calculation is 66,426.91, and the mode for SPSS calculation is 1,826.84, where the SPSS calculation is lower than the manual calculation. As for the mean for each statistic is by manual calculation is 40.4047, and for SPSS calculation is 39.98. This situation indicates manual calculation produces better result than SPSS calculation. For variance and standard deviation shows manual calculation. For manual calculation, the variance is 210.16 and the variance for SPSS calculation is 210.930. The standard deviation for manual calculation is 14.50. Meanwhile, for the SPSS calculation is 14.523. There is difference between both calculation because the manual calculation, the age distribution will be skewed to the left because the mean is greater than the median. Meanwhile, for the SPSS calculation, the age distribution will be bell-shaped because the mean is lower than the median. Outcome from the multiple regression equation for the body mass index BMI by using SPSS reveal BOR is negative 4,184.182, which assuming that other factors like BMI remain constant. The cost for every unit increase in age are predicted to rise by 314.044, and if the participants are the same age, each unit rise in BMI will boost expenses by 182.687. Finally, we have concluded that the link between age statistics, charges, and the BMI as established by manual calculation and SPSS analysis is the association between the most important and logical factors. Thank you.